Now let's look at to the exercise 1. Find the domain of the following function. So to determine the domain of any log function, it depends on the values of the argument. So for the argument, which is x, must be always positive or x must be greater than 0. So that's why we get the domain in general for the log function is open bracket 0 until infinity, and with the range from negative infinity until infinity. So for the first function here, fx is equivalent to log x minus 1 with the base 2. So we just focus on the argument terms. So in this case, our argument is x minus 1. So it must be greater than 0. Therefore, x must be greater than 1. So to rewrite in terms of interval notation, so we will get open bracket 1 until infinity. So this is the domain of the function log x minus 1 with the base 2. Now let's look at to the next one. The function is log x squared minus 3x with the base 3. Therefore, in this case, our argument is x squared minus 3x. So that argument, x squared minus 3x, must be bigger than 0. So since we have in terms of quadratic here, which is x squared, so it shows that, and it is inequality. So there are two ways to solve this inequality. So it's either by using quadratic graph, or we can use the sign table. Since it is in terms of quadratic, so it's better for us to apply or to solve by using graph, because we will save a lot of time. So we have x squared minus 3x. So what we have to do before we proceed with the graph, so we have to factorize completely the term. So we will get x minus 3 greater than 0, and from here we get two zeros, which is 0 and the values of 3. And from that two zeros, what we have to do, so we will draw the smile graph here, because a is greater than 1 and our zeros, the lowest is 0 and the highest is 3. So since it is greater than 0, therefore this is the shaded area. So as a conclusion, the domain of this log function is from negative infinity until 0, open, union 3 until infinity. Okay, now let's look at to the question number 3. So log with the base 3 of this argument, so we just take out that argument, which is x squared plus 2x minus 3 divided by x minus 2. It must be always greater than 0. So again, this is how we have to solve this inequality, like how we solve the inequality in terms of rational in chapter 1. So we have to do, what we have to do next is we have to make sure everything in the complete factorization. So in the denominator is already in terms of complete factor, but in the numerator we need to factorize completely. So we will get x plus 3, x minus 1, and divided by denominator, which is x minus 2, and this term must be greater than 0. So don't ever split between all these factors, like x plus 3 greater than 0, x minus 1 greater than 0, x minus 2 greater than 0. Please don't ever do this. So it is definitely wrong. So after you already put in terms of factor form, what you have to do next here is you have to take out the zeros. So we have 3 zeros because we have 3 factor, which is negative 3, 1 is the zeros in the numerator, and in the denominator we have a zeros of 2. So we have 3 zeros here. What we have to do next here is, because it is in terms of rational, the only way for you to solve this is inequality is by using sign table. So we will have 4, 1, 2, 3, 4 column, because we have 3 factors here, with the last row is referred to the resulting sign. And the way how you put the factor, it's better for you to put the factor of the numerator first. So for this one, I will put here as resulting sign. So I will put the factor of the numerator, which is x plus 3, x minus 1 and x minus 2. So there are two ways for you to write down the terms on the first column here. So it's either you want to put in terms of negative infinity until negative 3, negative 3 until 1, 1 until 2, and the last column here 2 until infinity. Or the other way, you can just write down the zeros, which is the lowest is negative 3, and then we have the next one 1, and then the next one is 2. So it's up to you. As long as you have to draw this sign table and then put the sign for each factor. So for the first factor, if you have a test point of negative 4, so for the first factor here, we will get negative. The second one also we will get negative, and the third one also we will get the negative sign. So we will have negative, negative, negative. So same goes to the next interval here from negative 3 until 1. We can choose the values of 0. So when you substitute, you will get the sign for the first factor here is positive. Next, negative. This one is negative. The next one, let's say we choose as 1.5. So you will get plus, plus, negative. And the last one, let's say we choose the values of 3. So you will get all the factor as positive. So the next one, what we have to do here is we have to find out the resulting sign. So since the arrangement is x plus 3, the factor of x plus 3 times with the factor of x minus 1. So for you to determine the resulting sign, the negative number, when you multiply with the negative number, so you will get positive, and you must divide by the negative sign, so negative. So positive number, when you divide by negative number, so you will get the negative number. Therefore, the resulting sign here should be minus. Same goes to the next column. Positive number, you multiply with the negative number, you have to divide by negative number. So you will get negative on the numerator. In the denominator, you will get negative. So negative number, you divide by negative number, so you will get positive. So same goes to the other two column here. You will get negative and positive. Then the next one, you have to choose the resulting sign. So since it is greater than, so we have to choose the positive resulting sign. Therefore, the final answer for the domain is negative 3 until 1 open union 2 until infinity. So that's all. You can try out the rest of the question number 4, 5 and also 6. You can check the answer from my slide presentation answer. Okay, thank you.